I am Nishriyas Vagalwadi, your science teacher, Sankalp Learning Solutions. In the last class, we discussed regarding carbon and carbon compounds. We discussed two special properties of carbon, that is low melting point and boiling point, as well as the one more point is nothing but it will not gain or lose electron, it will form the covalent bond. So the reasons for two properties we discussed earlier. So it is due to the formation of the covalent bond. How the covalent bonds are formed, that also we discussed. We discussed two examples of covalent bonds, that is oxygen and hydrogen. Let us discuss few more examples so that we will get to know, we'll understand the concept in clearly. And as we know that this electron dot structure is very important for the exam point of view, I am solving more examples. So let us take here. The next example is the third one, nitrogen. Nitrogen. So in the nitrogen, what is the atomic number of nitrogen? 7, right? So here the electronic configuration will be 2 and 5. So the last shell has 5 electrons. So it needs 3 more electrons to get octet electronic configuration, right? Here, to get octet electronic configuration, it should get 3 electrons. How it will get? Otherwise, it should lose 5 electron, which it needs more energy to lose that electron. Otherwise, it should get addition of 3 electron. But the 5 electron managing the addition of 3 electron, again, it will be problematic for it. So it will think to share the electron. To share the electron with which atom? With its neighbor atom, with its nitrogen atom itself. When there are same atoms, they can share with a very, we can say, the people, the students which are, I mean, your friends will be from your same division, your friendship will be good. So if you are from different division, you are the friends, but it is not so much close as your same division friends. So like that, the nitrogen combines with the nitrogen atom. So here what happens, let me draw the dot structure directly. So nitrogen has 5 electrons, right? So 1, 2, 3, 4, 5. The other nitrogen also has 5 electrons. So this electron, this nitrogen atom needs 3 electron. This nitrogen atom needs 3 electron. So that they will get octet electron configuration. So let us see that. Okay, check the electron. 1, 2 with this atom. 3, 4, 5, 6, 7, 8. So the outer shell got 8 electrons. Similarly, with this nitrogen atom, check it. 1, 2, 3, 4, 5, 6, 7, 8. So by sharing 3 electrons among themselves, each nitrogen atom got 8 electrons in its valence shell. So nitrogen will be stable in the form of N2 nitrogen molecule. As 3 pair of electrons, 1 pair, 2 pair, 3 pair. 3 pair of electrons are shared here. The covalent bonds will be 3. Nitrogen binds with the other nitrogen atom with 3 covalent bonds. This is how we have to draw electron dot structure. So this is between the same atoms. Let us see with the different atoms, the molecules with the different atoms, hetero molecules, what we will call. So let us consider one more example, the special example, that is ammonia, guys. Ammonia. So what is the formula of ammonia? NH3, right? Nitrogen, 1 atom, 3 atoms of hydrogen. So for this, what is the atomic number of nitrogen? So the atomic number of nitrogen is 7, and electronic configuration as usual 2, 5. Hydrogen is 1, K is 1. So here what is happening? It needs 3 electron to get octet electronic configuration. It needs only 1 electron to get octet electronic configuration. So if there is a bond between nitrogen and hydrogen, hydrogen can give only 1 electron. One hydrogen atom can give only 1 electron to the nitrogen so that it becomes stable. But it is in need of 3 electrons. So what happens now? We want 3 hydrogen, right? So if 3 hydrogen, among 3 hydrogen, 1 hydrogen will give 1, 1 hydrogen will give 1, 1 hydrogen will give 1. So total 3 electrons are donated, are shared by the hydrogen atom so that they will get the, they will bind with the covalent bond. Let us see that. So let me consider nitrogen. What is the 1, 2, 3, 4, 5. Okay. Here, 3 hydrogen are there. So we will take, we will write like this so that it will be used easy for us to draw the dot structure. 1, 2, 3, 4. Somewhere here we will draw 5. So 5 outer shell, I mean valence electrons are there. So this is a nitrogen. So it wants 3 electron from hydrogen. So as we consider, we want 3 hydrogen, H. Here we will write H. Here we will write H. So here hydrogen will be having one electron in their valence shell. 1 electron. This is 1 electron. This is 1 electron. And they need 1 hydrogen to 1 electron to get satisfied. So what happened here? Just see. Okay. Next. So here, when you count 1, 2, 3 for nitrogen, okay? 1, 2, 3, 4, 5, 6, 7, 8. It got 8 electrons. And hydrogen, this hydrogen needs 2 electrons. 1, 2. This hydrogen needs 2 electrons. 1, 2. This hydrogen needs 2 electrons. 1, 2. So here electrons are being shared by 3 hydrogen atoms to 1 atom of nitrogen. That is how formation of this one, ammonia takes place, right? So this is the electron dot structure of ammonia. Similarly, we will take an example of another carbon compound which is methane. The other carbon compound which is methane. Which is fifth example, right? Why I am solving more example? Because it is very important. The formula of methane is CH4. Carbon 6 electronic configuration. 2 and 4. Same hydrogen 1 electronic configuration. 1. So as we know the formula as CH4, here you should know that here 4 hydrogen atoms will be donating the electron to the carbon. Here, as L has 4 valence shell, it needs 4 more electrons to become octet electronic configuration, to get octet electronic configuration. So here, if 4 hydrogen atoms, share 1 electron each from their side, 1 hydrogen will give 1, 1 hydrogen 1, 1 hydrogen 1, 1 hydrogen 1. So 4 hydrogen will give 1 electron each. So 4 electrons will be shared with the carbon. Like that electron will be shared, that 1 electron will be shared with the hydrogen, where both the atoms will become stable. So that sharing of electron forms the covalent bond. Let us see that. Let me first write the carbon. So it has 6 electron, right? 1, 2, 3, 4, 5, 6. Okay. Now we will take the hydrogen, 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 hydrogen. So hydrogen is having one electron. So sorry, it means 4 electrons are there. 1, 2, 3, 4. Fine. Then for our understanding, let's make like this. 1, 2, 3, 4. 4 electrons are there in the valence shell. So here the bond formation takes place. Okay. And this is a hydrogen electron. So the hydrogen will be sharing one electron from this atom. And again, the hydrogen shares it with same way this, same way this, same way this. Now count the number of electron guys around the carbon. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. Similarly, with this hydrogen, 1, 2. 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 So hydrogen is satisfied with its number of atoms. Carbon is satisfied with its number of atoms. So like this, methane molecule is formed by the formation of covalent bonds. As you can see that it will be sharing 4 electron. It will be sharing 4 electron. So there 4 valence bonds will be there. The carbon will be having 4 free hands so that it can give the hands to any atom. That is the reason it can form cross together of compounds. It is because of it has 4 hands. 4 valence electron, it has 4 valence electron. You can tell me the other elements in the periodic table like silicon and all. They also have 4 electrons in their valence shell. But here the atomic size of silicon is quite larger than compared to carbon. That is the advantage. The atomic size is smaller and it has 4 hands. Okay. So this is regarding the formation of a methane molecule. Like this, you can also write the formation of a carbon dioxide molecule using electron dot structure. So carbon needs 4 electrons. Oxygen can donate in the requirement. For example, 2, 6. So it needs 2 electrons. So here, as it needs 4 electrons, we will take 2 oxygen atoms. So you can also form the draw the electron dot structure for carbon dioxide molecule. It is the homework for you all. Do it. Right. Next, we are going to study about one of the main property of a carbon, a very interesting property of a carbon. So we all know that regarding the diamonds, right, which are used in the ornaments. So whatever the diamonds are there, no diamonds, when you just check it physically, it is a very hard substance. And you know what it is made up of? It is completely made up of the carbon. So here, the carbon atoms are arranged. The carbon atoms are arranged in the form of a three-dimensional structure, guys. Okay, three-dimensional structure. Then we have one more one more element which is called as graphite, in which is also made up of carbon. But here the carbon atoms are in the form of hexagonal, this one, hexagonal plates like which are attached. Somewhere they will be attached with a double bond, right? So like this, the graphite and diamond, even though they are made up of carbon, graphite is very soft and smooth, whereas diamond is very hard. Diamond is very hard. And diamond is shiny, it gives shine. But graphite looks dull. So here what happens? Even though chemical properties of both the things are same, they differ in the physical property. So carbon has so many examples like that. So it has varied number of substances which have different physical properties but have same chemical properties. So such substances are called as allotropes. So graphite, diamond, these all are allotropes of carbon. Carbon has a capacity to form varied number of allotropes. Allotropes means the substances which will be having different physical properties but the same chemical properties. Right? So like this, the carbon has one more structure or one more what we can say substance which is called fullerenes. It is called as fullerenes. So its structure is nothing but the carbon atoms are arranged in the form of a football over there. In the form of a football, fullerenes. Okay. So here, why it is named fullerenes? Because it looks like a icon which is prepared by Buckminster Fuller. So that is why it is called fullerenes. So this is how carbon has varied form of physical property and but the same kind of chemical property means it has varied number of allotropes. This is also one of the special property of the carbon. So today we learned regarding the formation of the electron dot structure, formation of the molecules, and also we learned regarding the allotropes. So here the diamond, what I said. So this diamond is made up of when the carbon is undergone with a high temperature and pressure, diamond is prepared. It is widely used in many industries like glass industry and all. And we know graphite. Graphite is used in our pencils and all, right? So this is how the special properties of carbon continues in this chapter. Let us learn those properties one by one in detail, okay, by understanding it, by enjoying it, okay. Until that, take care. Have a nice day. Bye bye.